In today's video, I am going to give the solution for the problem in complex integration. Now, in this video, we are going to verify Cauchy's theorem for the integral z cube taken over the boundary of the rectangle with -1 plus 1, 1 plus I, -1 plus I. And see, what is the function here? So, the function, it is given as a z cube. So f of z is given as a z cube. As you all know that what is z value? So z is nothing but x plus I into y, and dz value will become, this is dx plus I times of dy. And now see what are the points given here. The points are nothing but, so this is -1. So -1 can be written as, this is the real axis and the imaginary axis here is 0, and this is +1. So here the real part is 1 and the imaginary part we don't have this one, my I into 0, and this is 1 plus I and this is -1 plus I. And see how I'll plot this. So this is also so simple. As you know that this is x-axis and this value is y-axis. As you can see that here this is 1, 0. So this is the point 1 on x-axis and this is the point -1 on the x-axis. Here y-axis is 0. And see, so this is our y-axis, and if you observe, if you consider this as the point 1, this is point 1, then see -1, 0. So this is -1, 0. This is +1, 0. And this point is 1, 1. So 1, 1 is nothing but the point 1, 1. So this value is nothing but -1, 1. So this is 1, 0 and this is -1, 0. So the points with respect to xy plane is -1, 0. And this value is 1, 0. This is 1, 1. So this point is 1, 1, x-axis 1, y-axis 1, and this is -1 and +1. See, so this is the point 1, 1, and this is the point, this is -1, 1. So it's clear. So the points which we have to represent is, so this is the point A, so this is the point B, this is the point C, and this is the point D, and this is y-axis, and as you know this is the origin point. So we consider this as curve C1, this is curve C2, this is curve C3, and this is curve C4, and along all these 4 curves we have to find the integral z cube. See here. So as you know that, so we have to consider along AB. So first of all, along AB, the points here, I'll show you along A and B. The curve is C1. So this is the curve C1. The point A is nothing but 1, 1. And the point B is nothing but -1, this is +1. So here if you observe, the y is a stable value as 1. So y is a constant value. Y doesn't change. This is 1 here. And x varies from +1 to -1. So y is equal to 1 and dy value is equal to 0. The derivative for constant value is 0. And x varies from the point, this is +1 to -1. Now I have to find out the integral value. So what is the integral value? That is integral f of z dz. F of z dz along the curve C1. So what is f of z? F of z is given as z cube. So this is z cube into dz. So what is z here? X plus iy whole cube into dz. So I said you dz is nothing but dx plus I into dy. So this is dx plus I into dy. So here in this, if I substitute y is equal to 0 and dy as 1. So here y is equal to 1 and dy is equal to 0, and the x limits are from +1 to, this is -1. See what happens here. So dy will become 0 and this is 1 to -1, y is equal to 1. This is x plus y whole cube into dx. So if I expand, this is 1 to -1. This value is a cube plus this is 3a square b plus this is 3ab square plus this value is plus a cube into dx. And now see the value here. As you know that I square value is equal to -1. If I square is equal to -1, so I'll show you what is I square. So we have to substitute I square value as -1. If we substitute I square is equal to 1, then this will be x cube plus this is 3x square I square -1, this is -3x, I square -1, so I remains, into dx. Now let us integrate with respect to x. So this value for x square, for x cube, this will be x power 4/4, and the constant here is 3i, and for x square the value here will be x cube by 3, and see again the constant here is -3, and for x the value here is x square by 2, and this value is -I, and integral dx is nothing but x. So between the limits 1 and -1. So if I substitute, this will be -1 power 4, it is again +1, 1/4, and see if I cancel this one, so this will be minus, so this is 1, so this is 1i, so this value is +I, so this is -3/2, and this is I, and see minus of, if I substitute 1 here, this is 1/4, and this value is +I, this is -3/2, and this is -I, and this value is nothing but -I. See the value here, I can cancel these two and see what happens. So this value is 1/4 -I, -3/2 -I, -1/4 -I, plus this value is 3/2 +I. So this is +I and -I. So this is +3/2 and -3/2. This is plus and this is minus. And see the value here is 1/4. This is -I, -3/2, and this is, see here, if I substitute the upper limit as -1, this is minus of minus plus. So this value is plus, and now I can cancel this plus and minus, and total I got the value. For curve C1 value f of z is, see, so for curve C1 f of z dz value is equal to 0. This is point number A. And now let us consider along along BC this time. So along B and C, see here, so this is the point 1, 0, and this is the point -1, 0, and so this is A point, this is B point. What is B now? -1, 1. So along BC I have to calculate, this is the curve C2. So along the curve C2, what is the B point here? -1, 1, and the C point is, this is -1, 0. Along BC, -1, 1, and here see x is stable value as 1. So here x value is equal to -1, and y varies from the point +1 to 0. So here the dx value is equal to 0. If I substitute all these in the integral along BC, f of z dz value is nothing but, along BC, the curve C2, this is z cube into dz. So this is, what is z cube? That is x plus I by whole cube into, this is dx plus I into dy. So here dx value is equal to 0. So dx is equal to 0. In place of x, I can write as -1. So if I substitute, this will be -1 plus I into y cube into I into dy between the limits. See here, y limits are from 1 to y is equal to 0. So if I calculate with respect to y, see here, then this will become, so this is a cube, so this is a cube plus this value is -3 times of a square into b, plus this is 3 a into this is b square, and this is minus iy whole cube into this is I of dy between the limits 1 to 0. So now if I expand, this is 1 to 0, minus 1 whole cube is minus 1, 1 square, this is plus 1, this will be 3yi. So this is minus 3 I square, this is I square, this is minus 1 y square, and I square, this is minus I y cube into I of dy. As you know that I square is equal to minus 1. So if I multiply with minus, see what happens here. This is 1 to 0. If I multiply with minus, this is minus I square, this is minus 1 3y, this is plus 3y square I square, this is minus of minus plus y cube into the value here is dy. Now if I integrate with respect to y, so minus I is a constant, and with respect to y, this is y, and this is minus 3 is a constant. For y, this is y square by 2, and this value is plus 3i. For y square, the value here is y cube by 3, and see here again the value for y cube, this is y power 4 by 4 between the limits 1 to 0. So if I substitute the limit y as 0, this will be 0, and this for lower limit, this is minus. So if I substitute in place of y as 1, this is minus I, minus 3 by 2. If I cancel these two, this will be plus I, and this is 1 by 4. And see, if I cancel this plus and minus, this is minus. If I take 4 as LCM, this is minus 6 plus 1, and this value is minus 5 by 4. The value here is plus 5 by 4. Therefore, along the curve BC, f of z dz value is nothing but 5 by 4, and please name it as B, equation B. So we have the value, see here for AB. So this is AB, along AB the value is 0, and this is equation A, and along BC the value here is 5 by 4, and C, and next along BC, and now along CD. See here, now along CD and C. So this is the figure. So this point is 1, 0, and this is minus 1, 0, and see, this is the rectangle. This is 1, 1, and this is minus 1, 1, and now see here, this is A, B, and C and D. So this is CD. So that C point is minus 1, 0, and D point is 1, 0. So if you see here, x value is stable value, x is equal to 0. Therefore, dx is equal to 0, and y varies from the point minus 1 to plus 1. So y varies from the point minus 1 to plus 1. Now we have to find out the integral. This is f of z dz. So this is nothing but z cube into dz. So z cube between the limits minus 1 to plus 1. So as you know that z is nothing but, see here y value is a stable value as 0, and dy is equal to 0, and x varies from the point. So this is the point x varies from the point minus 1 to plus 1. See, if I substitute here, so this is minus 1 to 1. What is z? Z is nothing but x plus iy whole cube, and dz is nothing but dx plus I into dy. Here if I keep dy is equal to 0, and see y value is equal to 0, and see what happens here, minus 1 to 1, this value is x cube into dx. See, it's very clear that y point, so this is y point and this is dy point. And see, this value is nothing but x varies from minus 1 to plus 1. So if I substitute the value, so if I integrate with respect to x, and this will be x power 4 by 4 between the limits minus 1 to plus 1. If I substitute the upper limit, this is 1 by 4 minus, if I keep minus 1 power 4, this is again 1 by 4. The value here is 0. Therefore, along CD f of z dz value is equal to 0, and just I'll name it as point C. And next, coming to the point along CD, along DA. See here, along the point DA and along DA. So what is the point D here? So in this case, so this is nothing but minus 1 comma 0, and this is plus 1 comma 0, and C, this is 1 comma 1. So this is the point A and this is the point D. So this is y-axis and this is x-axis, this is origin. So the point D is nothing but 1 comma 0. See, D point is nothing but 1 comma 0 and A point is nothing but 1 comma 1. And see here, x is fixed value as 1 and y varies from the point 0 to 1. See here, x is equal to 1, therefore dx is equal to 0, and y varies from the point 0 to 1. So if I substitute here d into a, f of z into dz, so this will be z cube dz. So what is z cube? This is x plus iy whole cube into this is dx plus I into dy. So here the y limits are from 0 to y limits are from 1. X value is equal to 1. So this is 1 plus I into y whole cube. And here dx is equal to 0. From this, what is dx? This is 0. And what remains here? Only dy remains. So if I multiply with this, now I have to expand. So if I expand, this will be a cube plus 3a square b plus this is 3a into b square plus this is b square. So this is b cube into dy. So this is I into dy. This is I into dy. The value here is I into dy. So this value is 1 plus 3yi, I square, this is minus, and this value is 3y square, I square, this is minus, I remains, y cube into I into dy. So if I multiply with I, this is I square, this is minus 1. So this is 3y square I square, this is minus 1, minus of minus plus 3y into dy. Therefore, the limits are from y is equal to 0 to 1, 1 minus 3y minus 3y square I plus y cube into dy. See here, for integral 1 into dy, the value is 1. This is 3y square by 2. This is 3y cube by 3 into I plus this value is y cube by 4 between the limit 0 to 1. So if I cancel and substitute the upper limit, so for upper limit, this is 1 minus 3 by 2 minus 1 plus 1 by 4. If I keep 0, so everything will be 0. So this value is nothing but, see here, the value for this is, so if I take 4 as LCM, this will be minus 6 plus 1, and the value here will be minus 5 by 4. See the clear? So along DA, f of z dz value is equal to, this is minus 5 by 4, and just I'll name it as D. So now, so this is our C value, so this is our B value, and this is our A value. And now let us substitute here. So in order to find the total integral, that is integral f of z into dz from the question, see here, from the question, what is the question here? The question is nothing but, so this is the question, and now integral f of z into dz is nothing but the curve 1, that is z cube dz, plus the curve 2 f of z, that is z cube dz, and the curve 3, that is z cube dz, and the curve 4, that is z cube into dz. So what is curve C1? C1 curve is nothing but AB. So this is AB, and C2 curve is nothing but BC. and C3 curve is nothing but this is a CD, and this curve is nothing but D into A. So all the values are ready here. So what is according to B? See, I'll show you. So the first value according to the AB is value is 0, and according to BC, I'll show according to the BC value here, the BC value is 5 by 4. Just I'll place the value as 5 by 4, and along CD, see here the CD value I'll show, CD value is again 0. So this value is 0 along DA. Just now I have shown you this is minus 5 by 4. The value here is minus 5 by 4. So if I cancel, so this is 0. Hence Cauchy's integral theorem is verified. So f of z dz value is equal to 0. Therefore we have to verify Cauchy's theorem. Hence Cauchy's theorem is verified. So Cauchy's theorem is verified. So this is how we have to solve. Thank you so much for watching, and this is the most important question and repeatedly asked question. So have a look at this, please practice and pass it on to your friends.